Okay, guys able to see this, or do you want to make it a little bigger?
Maybe a little bigger.
How's that? Is that good? Okay, so it's a molarity problem. What is the molarity of a solution that contains 10 grams of silver nitrate that has been dissolved in 70 mils of water? So I will let you guys work on that first. So I have a bunch of problems, molarity and percent by mass problems, and then I also have some gas law problems as well. So I kind of have a little bit of everything that we talked about yesterday. All right. Molarity, my pen here. Molarity equals moles over liters. All right. So you have your grams right here of your silver nitrate. All right. So you have to convert that into moles. All right, and then it has been dissolved in 750 mils of water. But you're right. So this is liters of solution, right?
Good.
So if you remember that pretty much that the density of water equals 1 gram per mil. Remember from lab. So for every gram of water equals a milliliter of water. All right.
Okay.
So if I tell you that you have 750 mils of water, you have to take the 10 grams and add it onto the 750 mils of water.
Okay.
All right.
I think I have it when you guys are ready.
Okay.
Yeah, you can go ahead.
Oh, okay. All right, hold on. Let me just check something real quick. Okay, so you got to convert the grams of the silver nitrate into moles. So you have 10.0 grams of silver nitrate. And then you got to get the molecular weight of silver nitrate. I should make that one somewhere. 170, rounding it up a little bit. So you know what? I'm actually thinking in this case you can keep it at the 750 mils. Usually a molarity. Yeah, I told you to add it, but in this case you should keep it at the 75 mils. It's really for the percent by mass is when you go ahead and you add your solute and your solvent. This is actually worded weird. It usually says that has been dissolved in a total solution of 750 mils of water. So I know I just told you the other way, but in reality, for molarity problems, you should keep it just however much water that there is, that's how much you should use. Does that make sense?
I think so.
Okay.
I converted the 750 milliliters to liters.
Yes. Yeah, exactly.
Yeah. Okay.
Exactly.
Yeah, I think I did that right then.
Yeah. Yeah. So, hey, Pete, does that make sense?
It does.
Okay. I know I told you that way, but I was thinking of another problem. But, yeah, in molarity, it's usually whatever the volume is. Because we're not doing by mass. It's by volume. And that 10 grams of salt is not going to change our volume a huge amount. Mm-hmm. In fact, it probably won't change it at all. It's just when we're doing by mass is when you add them up. Okay. So that's basically how you do it. So you okay, good. Everybody
Yeah,
okay?
that's what I got. So
Okay, good.
Yep.
All right, good. So let's do number 2. Oh, I had to keep the other problem. Guess this asks you about problem 1. Okay, so in this one, what is the percentage by mass of the solution in problem 1? All right, so you guys want to try that on your own? Okay, so in this one, you're supposed to add them. So you see how I say here that the density is 1 gram per mil. So if I have 750 mils of water, we're going to assume that's 750 grams of water. So in this case, you'll just do 10 divided by 760 times 100. All right, as simple as that. That's an easy one. 10 divided by 760. So what times is that 1.3? So he's getting
Yep.
1.3. Let's say 2 because you should have 3. Well, 2 is okay. Let's just do that. 1.3. All right, good. You guys are good with those. Let's go to. Oh, did I just close it? Number 3. Actually, no, let's just make all these the same size. So I don't have to keep doing that every time. All right, there's 3. How do you create a 0.25 molar magnesium chloride solution with 5 grams of magnesium chloride? How much water is needed? So in this case, I kind of want you to explain to me how you'd make it. So, like, pretend you are a chemist, and in lab or something, I would tell you, here's 5 grams of magnesium chloride. You have to make a 0.25 molar solution with the 5 grams. So you have to figure out how much water that you're going to need in order to add to that. Does that make sense? So you kind of have to explain that. All right. You guys will get it. Information of 2 of them. So I have the molarity, which is 0.25, and then the moles. So I'm obviously trying to find out how much water. So that's my volume, my liters of water. The moles, however, has to come from the 5 grams of the magnesium chloride. So I got to take. The molecular weight, I think, is 95.3.
yeah, that's what I just got.
Okay. So you do this to find out how many moles is in that 5 grams. So 0.0525, rounded up. That's what goes right here. All right, does that make sense?
Yep.
And then you solve for liters. So 0.0525 divided by 0.25. So 0.21, that's in liters. So if you want to convert to milliliters, which makes it a little bit easier, so 21 milliliters. So what you're basically going to do is you take your 5 grams of magnesium chloride and you dissolve it in 21 milliliters of water. And you'll get a 0.25 molar solution.
Okay, that makes sense.
Okay. You guys want to try another one of these? Let me see if I have another one. Otherwise, I can find one more.
Yeah, that'd be good.
No, that's a different one. Okay. All right, I'll type it right here. Okay, so let's say let's do this. How many grams of, let's do hydrochloric acid. Well, no, you can't weigh out hydrochloric acid. Let's take sodium chloride. How many grams of sodium chloride are in 47 milliliters of a 1.32 molar solution? There we go. How many grams of sodium chloride are in 47 milliliters of a 1.32 molar solution? Molarity equals moles per liter. So I'm finding how many grams. Okay, well, obviously I can't find grams from the equation alone, but I can find moles. And what can you do with moles? You can then find grams. So 1.32 equals my number of moles of sodium chloride divided by, and remember, this has got to be in liters, so you have to convert that 47 milliliters into liters. So 0.047 liters. All right? Do you guys remember to do that?
Yep. That's what I have so far.
What's that?
That's what I have so far.
Okay, good. So 1.32 times 0.047, 1.32 times 0.047. So the moles equals 0.06204 moles of sodium chloride. And then I got to now convert the moles into grams. So let's see, sodium is 23, chlorine is 35.5. Right, about, so that's 58. 58.8, yep, grams. So times 58.8, and so you get 3.65 grams of sodium chloride. All right, that makes sense?
Yep, perfect.
Okay.
I got it.
Good. Yeah, I mean, this is kind of, it's an extra step we're adding in there. I mean, most problems in here are just basically, it's how many moles are there in this problem. But if you know how to get to grams, then you obviously know how to get the moles. So we're just adding a little bit more to it. But it's basically, all you're doing is you've got three variables, all depending on the information that's given. You have information for two of them. You'll always have to find the information of the other one. Okay? All right, good. All right, let's see. All right, number 4. How many grams of hydrogen peroxide are needed to make a 8.5% solution by mass of hydrogen peroxide if you want to make 450 grams of solution? How much water do you need? So there are two questions. One, how many grams of hydrogen peroxide? And then number 2, how much water is needed as well? We're doing percent by mass. So we have 8.5% equals, this is the mass of the solute, which is what we're trying to find. So hydrogen peroxide is the mass of our solute. So we're trying to find this, divided by a total of 450. So the 450, remember, is our total, is the mass of our solution, solute plus our solvent. All right, so your grams is going to equal 0. Let's see, move over 2 places, 0.85 times the 450. So 0.85 times 450. So we get the mass. This is the mass of our solute, which is our hydrogen peroxide, equals 38.25 grams. Is that what you guys get? I'm sorry, yeah. Yes? You guys get that? I can't hear you.
Well, I got it wrong because I did the math wrong, but I get it.
How'd you do it wrong? What happened?
I I just had a decimal point in the wrong spot.
Oh, okay. Okay.
I had 0.85 for some reason.
0. Okay. Yeah.
Yeah.
Let me just. Yeah, it's by 2. So 1, 2.
Yep.
Yeah, you have 0. Yeah. Yeah, I was doing that yesterday with the R value. I don't know what was going on yesterday. The R value had an extra 0. I've only been using that number for 20 years of my life. Just forget it. Okay, so that's the mass of the hydrogen peroxide, and then to find the mass of the water, you're going to take that number and subtract it from 450 in order to find the mass of water. 38.25. So the mass of water should be 411.75 grams.
Okay.
Okay. Did you get it, Kayla?
Yep.
Okay.
Got it.
Okay. Good.
Cool.
Okay. Good. All right. So those are. I think that's the last. Yeah. So those are that's the last of the problems of the concentration problems. All right. And then let's delete all that.
This problem sheet is on D2L stage?
I haven't put it there yet, but I will. There is another problem sheet there for all these chapters.
Okay.
So I'm just doing other problems other than what we have online. It's just
Gotcha.
additional problems. Yep. Yeah. So now we can do some of the problems, some of the gas problems. So if you guys want to do those, we can do those now. All right. Unless you want to do more of these, or if you have more questions. But that's pretty much it. I mean, the types of problems I gave you are the types of problems that you're going to see. They're very characteristic of the types of problems.
Yeah.
We did. Yeah.
What's that?
I just wanted to,
Okay.
I said, I think I'm good on the ones we just did. I
Okay.
just want to do like a practice sheet on my own just to kind of practice
Sure.
them. But
Sure.
right now I'm good.
Okay.
Yeah. I think it's good to do the gases.
Yeah. So let's do these. I think I have like 4 or 5. Let's see. 1, 2, 3, 4, 5, 6. I have 6 problems here on that one. So it's a little bit of everything on those. Let me just change that size real quick. Okay. So let's do this one. Put it on pause. So again, remember for this, for the gas problems, there is the combined gas law, P1 V1 over N1 T1 equals P2 V2 over N2 T2. And all depending on the question, you might not have to use all these variables. So like in this question, I have a liter and I have a pressure and a pressure. So I have a volume and a pressure. I don't have any information about moles or temperature. So those are not included in the problem. I just ignore them. So my equation is P1 V1 equals P2 V2. Does that make sense?
Yep, makes sense.
Okay. So it's basically a Boyle's law problem at that point. And then the other equation we talked about is PV equals nRT, the ideal gas law. And remember R is equal to 0.0821. And the units have to be atmospheres, liters, moles, and Kelvin. And then the other one is Dalton's partial pressure, where the total pressure is equal to the individual pressures. Okay, so pretty much for all these problems, it's going to be one of these 3 equations. And remember in class I talked about the way that you know it's going to be this equation is if you are given a 2 of everything. So if you start with 1 pressure and you go to another pressure, or you start with 1 liter. So in this case, notice I'm starting at this pressure and I'm going to a different pressure. So I know I have to use that equation. If I just had 1 of everything, if I just had a volume, 1 pressure, and a temperature, then I know I have to use that one. And then if there's a question where it's asking me for what's the pressure of this gas and of this gas. So if you notice in this problem, it's only 1 gas. So 1 gas is either this problem or this problem. If we start asking things where there's like 2 of the gases in there, then I'd go ahead and have to use that one. Okay? Okay, so I'll give you guys a little bit of time to work on this problem. So like I said, if we take the P1 V1 over N1 T1, I just have pressure and volume. So this is a Boyle's law. So one of the things, well, again, I guess you don't, I keep thinking we're in class, but in class, I was going to tell you guys that I'm not going to tell you that what Boyle's law is. I would just have P1V1 over N1T1, and you have to know what Boyle's law is, but you guys will have everything available, so it won't matter. So we're going to have 748 is our P1, our V1 is 22.5, and this equals 725, and we're looking for the final volume. If I don't tell you what unit it's in, just assume whatever unit your original one is.
Okay.
All right. But if I tell you what's the new volume in milliliters, and your answer solves it in liters, then you'll have to go ahead and solve it. All right. So 748 times 225 divided by 725 should equal our V2. All right. So 748 times 225 equals divided by 725. And I get 232. We'll just keep it 366. 232 liters. Good?
I think,
Did I do something wrong?
I got 23.2.
yeah, I think what you did
yes.
is you
I
put
forgot the decimal
liters.
point. Yeah.
Yeah, you forgot the decimal
Yeah, I
point.
couldn't see it right there. Yep, you're right. Yep.
That's
So-
okay, you're testing us to test you,
Exactly. Good job, guys.
I also forget decimal points sometimes.
Yeah. It's hard to write on this thing. Plus, I don't have good handwriting to begin with. All right, good. So you guys got that. Let's see, the next one is calculate. Calculate the decrease in temperature when 6 liters at 20 degrees Celsius is compressed. So, just for extra practice, so obviously do the problem. Also, see if you can remember whose law this is. All right. If you can't, obviously find it. But once you tell me who of the laws, Boyle, Gay-Lussac, Charles, or Avogadro. Okay. So we'll add that into the question as well. All right. I'm going to put this on pause. That's okay. And the temperature. So we are given V1. V1 is equal to 6 liters. And T1 is given to 20 Celsius. However, we have to convert that to Kelvin. So 293 Kelvin. There's nothing about moles, nothing about pressure, so I don't even have to worry about those. So those are not part of the equation. So the equation is V1 over T1 equals V2 over T2. So the V2, the second volume, is 4 liters, and I'm looking for T2. All right, so 6 divided by 293 equals 4 divided by T2. So solve for T2. T2 goes on that side, so we'll have T2 equals 4 times 293 divided by 6. And whose law is this?
Charles?
Yep, Charles' law. So I get 190, let's see, 368, so 195. That's in Kelvin. Now, if you want to keep it in Kelvin, that's fine, but since technically it is in Celsius, we start in Celsius, you can change it into Celsius. And if you did, that's fine. If you didn't, that's fine. So it'll be negative 77.7 degrees Celsius. Okay? You guys get that?
Yep.
Yeah.
Looks good.
And this is Charles' law. Good. All right, good. Moving right along.
I feel like these gas laws are just more simple.
Yeah, they are. I think in class I said that usually people don't have any problems on this chapter. This chapter is pretty straightforward. Again, the hard part is just knowing. Just remember you have to convert to Kelvin, knowing which equation that you have to use. And if you do an ideal gas law, you got to make sure that everything is in the right units.
Right.
So as long as you're on top of that, it's really not that hard. All right, so let's do number 3, and then in this one, notice you have volume, temperature, and pressure. So you're going to have P1 V1 over T1 equals P2 V2 over T2. And what is the volume? So again, we're looking for this. So your initial pressure is, what's your initial pressure? 740. And your initial volume is 106. And then your temperature is 273 plus 45, which is 318. And then pressure 780 V2 over 293.
Yep.
So solve for V2. I'm not going to spend time to do it. I'll just enter it. So you should get 740 times 106 times 293 divided by, is that 318? Divided by 780. So I get 92.7 liters. Does that agree with you guys?
Oh,
Yep, that's what I got.
Okay, good. Easy. If you had moles, okay. This one. I was checking to see if this is the same one, then we'll have to do it. I think we just have two more. Okay, good. Okay, so we'll do this one. If I have 17 moles of gas and a temperature of that and a volume of that, what is the pressure? I'll let you guys work on that. All right, this is an ideal gas law problem. P equals nRT. All right, you just got to make sure everything is in the correct units. You're looking for pressure, so P equals nRT over V. All right, you have moles, so it's easy, 17 times your R. Let me do it down here. I'm going to run out of room here. So 17 times 0.0821 times 273 plus 67, 340. Yep. And then 88.89 liters on the bottom. So 17 times 0.0821 times 340, all divided by 88.89. And so your pressure, this is going to be in atmospheres, is 5.34 atmospheres. Good?
Yep.
Okay. And again, if the question doesn't say otherwise, always assume it's in the units that everything is in. But if I said, what's the unit in torr, then you'd have to go ahead and take it and I'll convert it to torr or something like that. All right, good. Number 5. Do another type of, there we go. It's a little bit of a different one. A little more involved. All right. All right. Okay, so same type of problem. Again, P equals nRT. We are looking for the pressure. So P equals nRT over V. All right. In this case, we're not given moles, but we're given 80.2 grams of argon. So we can take the 80.2 grams of argon and figure out how many moles it is. So argon, the molecular weight of argon is 39.9. 39 point is actually 948, so we'll just keep it exactly how it was. So that is, you can see I like these problems within problems. It's also just to keep you on top of doing all these conversions. So it's 2 moles. So let's go back to our ideal gas law. So 2 times 0.0821 times your temperature, again, 273 plus 97, 370, divided by the volume, 45 liters. So 2 times 0.0821 times, what is that, 370? Divided by 45. So your pressure should equal 1.35 atmospheres. You guys get that?
Yep.
That's what I got.
Okay, good. Good job. Moving along. I think we got one more. Okay, one more. Okay, so this one, a sample of gas has a mass of this, occupies a volume of this, temperature of this, and pressure of this. What is the molecular weight of the gas? This is kind of like one of the problems that I was talking about yesterday. All right, remember that the units of molecular weight is grams per mole. So your final answer has to be grams divided by mole. That's the unit of your final answer. Okay? So I'm going to put this on pause. You guys let me know when you're ready, okay? Okay, so this question is how many moles of chloride ion are in 250 liters of a 1.50 molar calcium chloride solution? So you have to find out how many moles of chloride ions there are. All right, so I'm not going to say anything. I'm going to let you guys kind of work on it to see if you can figure out what it is. Again, it's going to take information that we learned from previous chapters. Okay? So I'll put on pause. I'll let you work on it for a little bit. And then if you guys need a little bit of help, I'll come back and help you guys, okay? Okay, so let's go over this. So this is a molarity problem. I give you molarity. So moles over liters. All right, so I'm asking you how many moles of chloride ions, how many Cl- ions are there? So that's what we're looking at. Remember, the structure of calcium chloride is CaCl2. So you obviously have to get the formula in order to figure out this problem. All right, so you have a molarity of 1.50. Your moles is what you're looking for, and this is going to be moles of calcium chloride. And you have your volume of 250. So your moles of calcium chloride equals 1.5 times 250. So when we do that, I think you get 375. Is that correct? Yeah. So your moles, I'll just do this. So you get 375, and that's moles of calcium chloride. And then you need to find the moles of chloride ion. So this is where you do a mole-to-mole conversion. So for every mole of calcium chloride, there are 2 moles of chloride ion. So it's basically 375 times 2, which is what, 750. So the answer should be 750 moles of chloride ion. Does that make sense?
Yeah, I got that right.
Okay,
Pretty
good.
happy.
Nice.
All right. Did you get a 2, Pete, or were you on the way?
On the way, for sure.
Okay.
I was having some issues setting it up as well, but I think I got it now.
Okay. Yeah, I mean, so if you think about it, if you do a picture, let me kind of do a picture of this. We're going to do it. Let's do this. Let's get the eraser here. Just erase that top part. So imagine you have a solution. So if you have like a solution here, all right, water, and you're adding in the calcium chloride, and it ionizes in here. You'll have calcium ions, but you'll have twice the amount of chloride ions. So however many of these ions you have, so it's basically saying whatever my concentration is, I'm going to have twice the concentration of the chloride ions, since for every mole of this, I have twice the amount of the chloride ion.
Right.
That's basically what it is.
Okay.
All right. So if I were then to ask, what's the molarity of the chloride ion, the answer is 3. Does that make sense? Do you guys see how I get 3? So
Yeah, that makes sense.
3 molar of the chloride ion. It's basically, it's this number, and it's times 2. Or you can take that 750 and you divide it by the 250.
Oh, okay.
So that's like the mathematical way. I mean, I guess it's all math, right? But if the molarity of the calcium chloride is 1.5, the molarity of the chloride ion is twice that. So what would the molarity of the calcium ion be?
The 6?
No. So just the calcium ion. So this.
Oh.
So since I only have one of them, it's going to be that 1.5.
Yeah, okay.
Yeah.
That's what I thought.
Okay. Yep. Good. Okay. Good.
Oh.
Any other questions?
I don't think so.
Okay. All right. Other than that, that's all I have for today. I mean, that's pretty good. It was about an hour and a half. So.
Awesome.
Yeah.
Wonderful. Thank you, Steve.
Yep. No problem. I will have a good weekend, and I'll see you guys on Tuesday.
All right, have a good day.
Okay. You too. Bye.